Here's Mr. Tal. I'll let him talk to you and start the talk. So enjoy.
Working. Great. All right, good morning. Good morning, everyone. Good. I'm getting an interactive audience. Good. So this talk is titled I Hunt TR-069 Admins. Let's get it started out. So, just a quick disclaimer here. Corporate legal wouldn't let us, actually do lots of this stuff, but you'll see. So, first of all, I'd like to credit my personal role model, which is InfoSec Taylor Swift, for providing inspiration, and words of wisdom, which I've tried to incorporate into some of the slides. So, yeah. But seriously, if you're not following this account, you should, because it's hilarious. Okay, so, an obligatory who am I? My name is Shahar Tal. Yeah, such profile pic, much coolness, very professional. I have an amazing wife and daughter waiting for me back home. I've just spent just almost 10 years as an officer in the Israeli Defense Forces. Last year I joined Checkpoint, where I lead a team in the malware and vulnerability research group. We occasionally do some interesting things, and hopefully you'll get to see more of us this year. So this is my right leg. Can you see that? Okay. This is my right leg. My left one has a hexadecimal dump. And if you want to see it, just come after the talk. So starting off with an agenda, I'm going to give you an introduction to what TR-069 is, okay? And, I'm going to tell you why you should care. I'm going to try to give you a sense of what the landscape feels like. We'll move on to show a few examples of pwnage and conclude with a short summary. So, just beginning with, residential gateways, sometimes referred to as home routers or SOHO routers. And we all know that this is an incredibly unprotected domain. In recent years, it just gives us more and more good examples of that. So we had the internet census, which showed us that there are literally millions of devices out there waiting to be controlled with default passwords. We've seen Rapid7's great coverage of UPnP exploitation last year, showing us that it's also quite easy to run code in so many devices. We've also seen campaigns targeting these devices for criminal activity. And there are really too many to mention, but some of these guys, maybe some of them are actually here, have been doing really great work, demonstrating really what is the state of affairs of this domain. And I'm here to kind of extend this notion. So what is TR-069? TR stands for Technical Report, which is kind of like an RFC, and contrary to what you'd expect, the title and numbering were not given by a giggling teenager, but a more or less respectable body called the Broadband Forum, which was previously known as the DSL Forum or the Frame Relay Forum. And they're basically known as, they're a consortium of many players in the broadband market, and they're attempting to find standards and common goals. So in 2004, they released the CPE WAN Management Protocol, and which is CWMP, or more commonly referred to as simply TR-069. And the specification went through 5 amendments, actually, latest of which released late last year. And to tell you the truth, it's a pretty boring 228-page document filled with, fancy words like mechanism specifications or schema definitions. And they actually describe pretty simple things. So let me try and summarize 200 pages for you. This is how TR-069 sessions or provisioning sessions work. Okay, on the right side, we have the CPE, which is the TR-069 client. That's your home router. On the left side, you have the TR-069 server, which is called an ACS, or an auto configuration server. And they talk in basic SOAP RPC, which is XML over HTTP, and it's that simple. it's important to mention that the client always initiates the session, which is a single TCP connection over which our RPCs are made back and forth. The client begins with an inform, which is stating the reason or why is this session initiated. And the ACS follows with provisioning functions such as get parameter values or set parameter values. It really is that simple. And there is a dual authentication mechanism. The CPE should make sure it's talking with the verified ACS, and the ACS should only accept sessions from authenticated CPEs. And here's a quick example, just to get you up to speed. This is an ACS set parameter value call for a certain CPE. And this is in fact, let me see if I can, yeah. Okay, so this is set parameter values call. And this is assigning a new value for the management server URL key, which basically means this is updating the configure ACS URL for this device for ACS supersecureisp.com, whatever. So these are only some of the names. Oh, sorry. You can see some pretty big names out there that have active TR-069 deployments. And as you can understand, this is not some obscure protocol. This is a growing trend to adopt it everywhere. And this is the widely used de facto device management standard. Yeah, so this research in 2010, it's estimated 150 million TR-069 enabled devices online, 70% of which are gateways, and today it's probably more. But how about this? Some very interesting results from the ZMAP guys, Zacher and his friends at University of Michigan. And they show that 7547, which is the default CWMP port, is actually the second most popular open port in the world in IPv4. This is no joke. This is a serious protocol. So let's talk about some of the functional use cases for TR-069. So what can you do with ACSs? You can provision devices, which is what you call zero-touch configuration. There's remote management by the tech support guys, when you call the call center and they fix your router, whatever they do there. You can monitor for faults, for malicious activity even. Diagnostics, performance measurements. You can replace, fix faulty configurations, and also deploy upgraded firmware. So I'm betting at least some of you are surprised with that last bullet, and this is where you start understanding the power that's entrusted in these sessions, right? So this is a power that service providers don't necessarily want you to know about. Think about this for a second. Without getting too deep into the trusting your compiler issues, who do you really trust to run code on your devices on demand? How about when it's done silently, remotely, with elevated permissions? I might trust some of these, very big vendors, like, like Microsoft, they have heavily protected update servers, whatever, I might trust them, but my ISP, I'm not sure. So yeah, ACSs have that trust, and they can remotely manage all the things. So here's a short story. This is my home router, or at least it used to be, and I'm starting to learn about TR-069, and I'm poking around looking for the TR-069 configuration, and there's no evident pages with these settings. I know you can't really read it from there, but nothing says TR-069. And oh well, I should go into expert mode, right? So, well, no, I'm an expert, so I go into expert mode, but still nothing. There's nothing saying TR-069. So maybe it's under remote management. I click it, and then no, that's only for web management, which is properly turned off, by the way. And this doesn't make sense to me because I know these devices have TR-069 enabled, and it's on the specs, and I've heard that my provider uses this. So as it turns out, my provider customized the firmware to hide the fact that they were in control, and this was done using the highly sophisticated HTML commenting technique. So you know, I enter a URL, and then there I get the details, and I have the setup screen. And you know, suddenly I see that there is no legitimate way to turn this off. So the disabling the informs is just like the periodic hello messages. That's, I mean, it still has no real effect. What you actually could do is change the ACS URL, but never mind about that. So, you know, in the later firmware version, they actually changed this page to be, you know, just a status page. Now there really is no legitimate way without, you know, getting a root shell on your device to turn off TR-069. And so the point is, you know, someone out there knows that they have a lot of power in their hands, and they clearly don't want me to know about it. So, with that context in mind, let's take a broader look on TR-069 architecture. And, sorry. Again, on the right side, we have the CPE, the client, which can also act as a proxy for many other home devices, such as VoIP phones, NAS devices, setup boxes, whatever wants to be controlled. And on the other side, we have the ACS. That's the, you know, the one server that's in control. On its northbound side, it is attached to ISP internal assets, like the, I don't know, OSS, BSS, billing, policy, the call center, of course. And the southbound interface is where the CPEs go. So, wait, what? There is a single machine in this design, you know, that's in control of an entire fleet of devices for that ISP, which would make it, in fact, the single point of pwnage. So, if ever there was a high-value target in an ISP, that would be it. Luckily, the southbound interface is using the most trusted and secure line that you can think of, which is the public internet. So, you know, looking at this from the APT or, you know, nation-state attacker's perspective, so you can take control of this one target, one accessible target, and you're in complete control by design over millions of devices. This is like, that's the NSA's dream right there. So, now that we all understand that TR-069 is very powerful, what could you actually do if you had control of an ACS? I see my shot coming up. So I'm just going to pause for that 1 sec. It's very dramatic. It's very dramatic.
You can keep going.
Okay, I'm going to keep talking. All right. So what could you actually do?
I see you've already taken your shot.
I apologize for that. It was a long night. You know, I copied all those Swift on security quotes like last night. So, what could you actually do if you had control of an ACS? You know, and that's a big if for now because we don't know how protected this is. But you can actually get private data. You can get the SSIDs, you can get the host names, MAC addresses, you can get the usernames, you can get phone numbers. With some vendors, you can get complete configurations, including passwords. You could set every parameter. You know, starting with the classic DNS change, right? We all know that one. You know, but you can go for more sophisticated stuff, like adding new hidden Wi-Fi. Shutting up.
Yeah, come on, you guys know the drill. How about a little love for the brand new speaker? Scumbag ACS?
Yes, sir.
What would an attacker do if... Maybe I should attend this talk.
That's right. This is a place right there. Okay, so you could add a new hidden SSID. You could add like a new Wi-Fi to that router and just connect to it whenever you're around. Or you can even replace the WAN service with an attacker-controlled tunnel. You could download logs, configuration, firmware from the device, and you can actually go all the way and custom bake your own firmware for all the clients of that. You can do this selectively. You can do this for everyone. This is crazy abilities. So now we understand this is a critical component in modern internet infrastructure, and with this understanding, let's go out and research TR-069. So, there's a couple of things popping up at Google when you look it up. And, there's Luca, which is the main developer for free CWMP. And it's an open source TR-069 implementations. But his talk is mostly about interoperability issues, and much less about security. And just a nice blog post by these guys, 3S Labs, and they actually made some few good points, but they never followed up with anything afterwards. And that's about it. And I mean, when we were seeing this, we were really surprised because, this is why we think that this talk is so important, because no one is talking about this shit, and this is important. We think more people should, and hopefully you guys will. And so why is that? And the problem is that this is software in a niche market. So, this is service provider world. This is out of most consumers and researchers' reach. Where's the TR-069 community, right? I mean, are there like TR-069 parties out there? I don't know. If I'm not invited, maybe I should. I don't know. I mean, how there's a subreddit for everything? I mean, nothing for TR-069. This is, we were looking for this, a TR-069 media outlet, something that covers, TR-069 happenings. And you know what? Apparently there is one. So this is actually a website called TR-069 Central. It's a WordPress blog, and don't laugh about it because they have 16 followers on Twitter. Yeah, let's see if I can. Yeah, they're following 23 people, including me. And of course I'm kidding, because they actually do a decent job of covering TR-069 happenings, and they have independent reviews and such. But and when I say they, I mean a pretty nice guy called Max, and they compiled a list of ACS vendors, some smaller names, some bigger players, and we start browsing the vendor sites. As you go along, you get this certain feeling. So let me try and show you what I mean. Let's hope this works. Wait.
Welcome to TriTech Australia.
Oh, really?
This presentation on bigger ACS SI, the latest offer from TriTech for TR-069 based auto configuration service.
This is great music, by the way.
Let's begin by logging into bigger ACS SI. Enter your username and password.
He's connecting using admin.
Network and devices fields will now open.
Okay, so that's maybe that's enough. The feeling is, much ACS vendors, very TR-069, many features, with such a 1999 look and feel, right? So, the more we read, the more we understand that ACS software are basically web applications that are filled with CPE-controlled values that go through lots of processing, and and we all know that clients can be like totally trusted, right? So we can look at TR-069 problems in two planes. So we have insecure configuration, and we have insecure implementation. Of course, we have the combination of both. More words of wisdom there. So how do you find ACSs in the wild? So first off, you can hack a single router, right? We all know that's kind of easy, and then you just get the ACS URL and you have one. But you can do more interesting stuff like, scanning. ZMAP, mass scan for the win. Well, just the last talk, I'll have this work. Scanning 7547 and friends. There's also UPnP endpoints, which are a lot of fun, actually. And there's public data sets you can search in, like the Internet Census and the DNS Census. Of course, there are some fun Google dorks if you're looking for a specific product. And of course, you can also go for, let me show them that for you, and look for interesting stuff there. But anyway, there are vulnerable ACSs online, I guarantee it. So how is ACS authentication performed? So SSL is recommended, which means that a whole bunch of lazy ISPs, avoid the trouble and just go with the shared secret, which is HTTP authentication, right? So either basic, digest, whatever. And we've actually done a little survey. We've collected a few hundred ACS URLs belonging to a few hundred ISPs. And would you like to guess how many of those were using HTTPS or SSL? So, yeah, here we go. So 81% were actually not encrypting any of this, super critical provisioning sessions. And this is like, what? What that means? That, with all it takes is one freaking, NSA quantum packet, a single quantum TCP packet to take control of a provisioning session and give you a new firmware or change any of the other parameters we just described. Here's a nice trick. So, router interfaces try to protect the ACS passwords, which is, how the ACS is supposed to know you're a real CPE. But as I've mentioned before, they allow you to change the ACS URL, which basically means that you can change it to a web server that you control, and even downgrade to basic authentication and just make it even easier to parse. So, yeah, nice trick. So let's talk about certificate validation. And the technical report states that if TLS 1.2 is used, then the CPE must authenticate the ACS using an ACS provider's certificate. That sounds reasonable. That actually sounds right. But this is how I imagine that this was perceived in most ISP management forums. And it's a little field test on this is obviously a fake certificate, right? It's a self-signed certificate that we just created for testing purposes. And so you claim to validate SSL certificates, but the fact that you accepted my self-signed one determined that was a lie. Yeah, so first Picard facepalm for the day. So let's run through a short recap until this point. So I hope you're convinced that TR-069 is dangerously powerful, and that TR-069 servers are high-value targets. And we've also seen that actual proof that a lot of implementations just aren't serious enough. And now we're going to take it to the next level. So at this point, I had to apologize in advance, because we wish we could have given some more details in some of the following slides. But however, we do realize that there are many unpatched instances out there, and we don't want to make it too easy for the bad guys. So our first target was a Java-based open source project. It's called Pwning ISPs. Start auditing the code, and 3 days later we get a remote code execution. So yeah, reflection and file upload. And this is like, you know, at this point, we're like, hey, this is exactly what we expected to find, right? We expected to find poor code. This is awesome. I mean, let's keep it up. So we move forward. We pick Pwning ACS, which is, you know, another open source project. This was fairly modern. It's under active development. It's running Node.js, MongoDB, all the new hip stuff. And we start auditing, and 2 days later we get a functional remote code execution exploit. So this is actually kind of nice. Let me try and show you that. So this is a regular expression that's, you know, filtering out bad characters in an input that follows to JavaScript's eval. But they forgot the G at the end of the regular expression, meaning that you put in one bad character and it just removes that unless you do whatever. And the real bad thing is that this is running as root. No JS servers. Yeah, this is bad and lets you dump like Etsy Shadow and stuff. Yeah. That would be our faces when we saw this. Moving on, some more pwnage. So here's some green text for you. Be scanning IPv4 for Pwning ACS. And we detect an instance, a vulnerable instance, in a Middle Eastern ISP. And when I say Middle Eastern, I'm talking about a major, very Muslim state. And you know, the northbound interface is exposed, which means the internal API, you can actually make calls to the internal API, which means that we own that. And then we're like, you know, facepalm. But OP actually delivers the vulnerability report. And the ISP support center was not thrilled with an Israeli calling about vulnerable infrastructure. But, you know, but we showed them this, and it's practically all blanked out. But, you know, it's a few thousand devices. They had it. 8 out of 10 would report again. So, yeah. I mean, what the fuck, you're leaving critical internal asset listening to the entire world, no protections whatsoever. The next case is kind of a big one. We can't disclose the vendor at this point in time, but it has a massive install base and it's deployed globally. And our findings include the internal API authentication bypass. We have a few SQL injections there, and a denial of service attack. The combination of which allows writing arbitrary files to any location, including c/inetpub, to an ASP-enabled internet server. So, you know, remote code execution, right? And we went ahead and contacted one large provider to test this with permission. And eventually, we ended up owning just over 500,000 devices. And this is, you know, in a major ISP. And this is just an example provider. We just picked one. And you know, this has been unpatched for at least 2 years now. So it is very possible that we're not the first to discover that flaw. But we don't really care. Appreciate it. Appreciate it. So, you must be asking yourselves, what can I do? I mean, what can I actually do? Because if you don't trust your gateway, there really aren't many things that you can do. But you know, adding another security layer, well, first of all, you can hide under the couch and never connect to the internet, but that's obviously not a good solution. So the first thing you can do is, you know, audit your own TR-069 settings. You know, actually ensure that, you know, SSL is turned on, that there is proper certificate validation. You know, if you're unsatisfied, you can disable it, if you can disable it. And you know, adding another network security layer is not bad. You know, you can add another router with NAT or firewall capabilities. I mean, we sell these devices, but actually, I mean, quite frankly, you can use open source firmware alternatives, and they'll do just great work. And you know, ask your provider about their TR-069 configuration. That's, I mean, it's their responsibility. So, trying to fix the problem. So there is no easy fix because the bad implementations are out there. So TR-069 has to mature more. Awareness is key. You know, this is what we're here to do. TR-069 can be secure. And this is up to the security community, which is you guys. We're hoping to get as many, you know, new research blogs out there as we can find. And ACS vendors, they have to start, you know, writing better software. Put your money in secure coding. I mean, show your security stance. I've never seen a bug bounty for TR-069 software, and I think we should. Service providers, I mean, you're the owners of the traffic. You have to protect your customers. That's your responsibility. So for some future directions, we're actually currently looking to extend this research. So you remember how 7547 is the second most popular port in the world, and this is by design. So we're looking into some client pwnage. Stay tuned for CCC. So this opens up an interesting exploitation vector. Right. Thank you very much.